This is Mr. Peterson, and I'm going over the notes for section 1.3 in Math 31 for Longview College. This section deals with adding and subtracting of whole numbers, and the application would be a few problems on perimeter. Okay, a couple of things about properties of addition. Some of the things you can count on when you're dealing with addition. One of them is the identity property of 0. That's usually just called the identity property. And what it is if you add 0 to a number, you'll get the identical number right back. So in the example here, we start with an 8, and once we've added 0 to it, you get the identical 8 right back. Pretty simple concept. Problem is remembering the name. Okay. The second one that we're going to look at is called the commutative property of addition. And this property states that if you put the order and mix them up, it doesn't make any difference. So if you start with $3 and add 4 to it, you'll get $7. But if you start with 4 and add 3 to it, you still get $7. It's equal quantities no matter the order that you put them in. So I like to kind of tie the name in with this idea, switching places, 3 and 4 and 4 and 3, for example here. I live in Shawnee, Kansas, and I teach in Gardner, Kansas. So in the morning, I go from Shawnee to Gardner, and then I turn around and go Gardner to Shawnee, and I'm just switching the order in which my destination and my origination, they switch places here. And so that's my daily commute, and there's the tie-in with the idea and the name. Okay, the next one is the associative property, and to associate just means to group. So my associates are those who are in my group of teachers. They're my associates, fellow workers. And in the first example here, we're associating or grouping the 7 and the 4. So 2 plus 7 plus 4, but we're grouping the 7 and the 4 first. That's a mechanism with the parentheses here, prioritizing. So you're going to say 2 plus 11, and that gives 13. But you take the same problem and group it differently, putting the 2 and the 7 together. Instead, you'll get 9 plus 4, and you still get 13. So if it's grouped differently, addition still gives the same answer. That's the kind of the explanation of what's called the associative property of addition. Okay, the next goal I have here is to actually show you how to add whole numbers without pulling out a calculator. You just go column by column, starting at the least significant column, which is the right hand, the ones column. So what we have here is 8 plus 5 is 13, but we run into a problem here. The place value columns can only hold one digit at a time, so you carry the 10 and keep the 3, and that's your 13. And it's like the directions on a shampoo bottle. You wash, rinse, and repeat. So we'll add these columns. The only change now is that we do include this carry that we brought over. That's now part of what we add. So we're going to go 1 plus 7 is 8. 8 plus 4 is 12. And we put the carry and the remainder there, the ones part of that. Okay, so then the next column would be 1 plus 3 plus 9 gives 13. And then finally 1 plus 4 plus 2 is 7. And our answer is 4,323. Okay, here's an application to a perimeter. And you're going to have one like this on your homework where you have to figure out one of the missing sides. This side up here is 27. This side here is 72. This right-hand part is 24. And the height of this thing is 68 yards. But this little section down here is not labeled. And what you have to know here is that the opposite sides of a rectangle are the same length. So I'm going to take this 27 and I'm going to bring it down here and apply it to this length. So that must be also 27 yards. So now what we're going to do is simply add all of the lengths until we get all the way around it. And I usually go clockwise, starting at the top left or something like that. It really doesn't matter the order. Remember, the commutative property tells we can go in any order we want. So I've got them all listed over here, and I'm going to add this column. 7 and 2 is 9. 9 and 4 is 13. 13 with 7 added is 20. 20 and 8 is 28. So we'll put the 20 as a carry and the 8. And now we're going to just add this column. Don't forget to include the carry mark. So there's 4, and 7 is 11. 11 and 2 more, 13. 13 and 2 more, 15. 15 and 6 is 21. So our grand total here is 218 yards. That's the distance around that yard or property. Okay, we've got a couple more examples of just adding here. So I'm going to add up this right-hand column. 6 and 4 is 10, and this gives 3 more, so 13. I'll add up the next column. 4 and 8 is 12. 12 and 7 is 19. 19 and 7 is 26. All right, and then we're going to go 6 and 5 is 11. 11 and 9 is 20. And finally, 2 and 2, the carry mark plus the 2 that was in the original problem there in the thousands column is 4,000. So our answer is 4,063. Okay, on this next one here, I'm going to do something a little unorthodox. You'll see it about halfway through the problem. Okay, 9 and 8 is 17. Nothing changed there. So we get 1, 5, and 1 add up to 7. Normally you would write the 7 and you wouldn't put any carry mark. I'm going to suggest that if you put the little 0 there, you'll keep track of where you are in the problem. So you don't have to put that 0 there. It's not how normal people do it. It's how your kind of quirky little teacher does it here. So if you add 0 plus 2 plus 8, you get 10. And adding the next column gives a total of 8. So I'm going to put a 0 as my carry and an 8 here. And that little carry mark tells me I'm now working on that 10,000ths column. So it just kind of helps you keep track of where you are in the problem. Is the only advantage of putting that extra 0 in there. 0 plus 8 is 8. So we get 88,077. Okay, in this next problem section, we're going to learn the parts of the subtraction problem. The number from which you are subtracting is called the minuend. The number that you are subtracting is called the subtrahend. And the resulting value is called the difference. Sometimes I get these mixed up myself. In fact, I may have taught your class wrong. It's not that important. The one that I care about the most here, to be honest, is the difference. That's the result. But these words, minuend and subtrahend, are really not used even very often in a math classroom. So here we go. Label the minuend minus the subtrahend, and you'll get the difference. And this one here, the minuend is the top number minus the subtrahend, and you'll get the difference. Okay, with subtraction, if you're lucky, you don't have any borrowing to do. This problem is constructed like that. So 8 minus 4 gives 4. 4 minus 1 gives 3. And if you really want to know, that's actually 40 minus 10 gives 30. But we just treat it as if that column is just single numbers there. And 7 minus 3 is 4. So the answer here is 434. Okay, the borrowing problem shows up in the next one here. And give me a second here. I'm going to set up a really fine pin to do this in so that you can see the original numbers. Our issue is that 1 take away 8, you don't have enough to take away 8. You're going to have to steal from the neighbor. This is 40 and 1 next to it. And if I take one of these, 10 of this, and decrease it to 30, you'll see what's happening here. I'll make that a 3, so the 40 just dropped down to 30. The extra 10 comes over here. So now you have 10 and the 1 that was there. In other words, 11. And it looks like 11 if you write it that way. 11 minus 8 is 3. Then you have to borrow again. This 3, which is really a 30, is not enough to take away that 7. So we're going to borrow. You take away one of the hundreds and bring it over here. So 13 take away 7 is 6. And then 1 take away the blank. The blank is a 0. And 9 take away blank. So 9,063. Okay, sometimes you have to borrow, not the neighbor's broke, and you have to borrow from a couple doors down. So what's going to happen here on this first column here is that the 0 take away 8, we don't have enough. So we're going to steal from the neighbor, but the neighbor is actually broke. So you have to take these two in conjunction, and you cross it out and say 39, and then put your extra 1 that you stole over there. So 10 minus 8 is 2, 9 minus 6 is 3, and 3 minus 1 is 2. Okay, here's a problem that's given to you as an addition problem with missing information. Ellie gained 15 pounds eating cafeteria food during her freshman year, and she weighed a total of 137 pounds at the end of the year. So what was her original weight? So what we have is an unknown plus 15 pounds of additional weight is equal to a total of 137. Well, the strategy is just to back down this ladder by subtracting instead of adding. So I've got the subtraction set off on the side over here. 5 taken away from 7 gives 2. And 1 from 3 is also 2. And then 0 from 1 is just 1. So she used to weigh 122 pounds when she started her freshman year. Okay. Politically incorrect to include weight, but you really don't know who Ellie is, and she's not unhappy with me because she's fictitious. All right, so this next one here is a chart. We want to read everything about it here. Let's see, this is the employment change. So these positive values here indicate that there's more jobs available in those fields. The years are the decade from 2008, I believe that was the first year Obama was in office, to 2018, a couple years ago. So this is about, this is a 10-year period. And the employment went up in these specific fields, especially in this last one, home health aides. So we have computer software engineers, physician's assistants, medical assistants, personal finance advisors, and home health aides. Now, there's something I'd like to highlight here that you have to keep track of. These numbers are in thousands. So, for instance, this number over here, the 63, is not really 63. It's 63,000 additional jobs. Okay, so the first question here is how much greater is the employment growth for the home health aides than the computer software engineers? In other words, how much greater is that than the big one than the small one? So we're going to subtract to get this answer here. 1 take away 5, we're going to have to carry, so I'll make this a 5 and put a 1 there, you get a 6. And that 5 take away 7 is not big enough, so I'm going to put a 1 there and make this a 3. 15 take away 7 is 8. And 3 take away 1 is 2, and we'd be done, except that we have to interpret this correctly. These are thousands. So there was an increase of 286,000 more home health aides than computer software engineers. Okay, combined total for the physician's assistants. Let me go back up there. Physician's assistants and medical assistants. So we're adding those two numbers when it says combined. And so we'll simply add these here. You get 13 in the ones column. You get 9 in the tens column, and I'll put a 0 there even though that's optional. 193. Oh dear, it's 1,000 times that. So you got to remember, if you're doing it this way, you got to put those extra zeros on this problem. Okay, so we're supposed to compare here the combined total for software engineers and personal finance advisors with the health aides. So we're going to combine software engineers, personal finance advisors, and we're going to compare it with that 461,000 figure for the other one. All right, so the first task here is to combine the total for the software engineers and the financial advisors. $238,000 versus 461,000, and you would write it like this: 268,000 is less than 461,000. If you were writing it out as an interpretation in words, you would say the combined total for the software engineers and financial advisors is less than or fewer than the home health aides. Okay, so that does it for section 1.3, and hopefully this is good enough for your homework.